and my project is how to perform outer join using Java Hadoop API. Yeah. Now, starting with joins. What are joins basically? When you have data distributed across multiple tables or data sets, and you want to combine the output and produce it in a kind of report, that is called as a join. Now, in order to join, you need a common key between the two tables. Now, there are different types of joins which are possible. First of all, it's equijoin, wherein if you have two tables, as you can see, you in equijoin you pull the common records between table A and table B and produce the output. Now there are the another kind of join is outer join, where both matching and unmatching records are picked. What does that mean is that this common set is picked as well as all these records which are not matching, like which exist in table A but not in B, are pulled in the report, and similarly all the records which are there in table B but not in table A are picked up. Now, in order to demonstrate outer join, I have used three data files as input. First is users. The format of the file is user ID, gender, age category, occupation, and zip code. For example, this row, user ID 1, the gender is female, age category is 1. Again, 1 does not mean age 1. It's a category which you would see, like, in the final output, what does 1 mean? And occupation 10, again, it's a kind of code or occupation code, which is later on elaborated or shown in the final output. The second input file is ratings. Again, the columns are user ID, movie ID, rating, and timestamp. For example, this means user ID 1 has rated movie ID 1193, given the rating of 5 on this timestamp. Now, one thing you got to note is all the files, all the input files are comma separated. Now, movies has three columns: movie ID, title, and movie category. Now, the output that we want so that we can demonstrate outer join is obviously we will have to pull the records from all the three inputs and combine and produce an output having all the three. So this is the output. This is how the output is going to look like. Gender, age category, occupation. These three are pulled from the users file. Rating is pulled from the ratings file, and title and movie category is pulled from the movies file. Now, as you can see, all the three um, are a combination of columns from all the three input files. Now, here is an example like gender F, which is a female. Now, here you can see that age category that was 1 in the input file, it has been expanded. 1 means it's under 18. And occupation was 10, like you saw in the previous example, and 10 stands for K to 12 students. Like all the students will have occupation ID 10. Now, ratings like this means that if the user has given a rating of 3 or more for a particular movie, I produce the output and say that that user likes the movie. Then this is the title of the movie and the category, what it belongs to, like whether it's a drama or animation or children's film. Now, for outer join, if a particular movie exists in the movie input file, but nobody has rated yet, so if you would have performed equijoin, this row wouldn't have been pulled up, but this row is pulled out in the output, final output, and in order so that it's easy to identify that this is the outer join row, I have added this particular text like not been rated, so that even in a report, like let's say if you have to produce a report for movies, which movies are liked and all by how many people like movies, how many don't like those category of movies, that kind of report. And but for a particular movie, you want to show that it's not been rated. This logic can be used. Now, oh, okay. One more thing. It's dislike when the rating for a particular movie is below 3. The report will show it as dislike. Now, in order to achieve the desired output, the logic how I have used is I have divided the task into two sections, or rather two jobs. The first job, what it does is it maps the users and the ratings input and produces an intermediate output here. So what it does is the first mapper produces user ID, gender, age category, occupation. And the second mapper in the same first job um, writes to the context, user ID, movie ID, rating, and the timestamp, all as a comma separated values. And the reducer, what it does is it picks up this movie ID, and when it writes to the context, this becomes the key, and the rest, all the columns, becomes as the values. The second job, again, it uses the output of the first job and the movies and produces the desired final output. Now, what it does is, see, the movie has a movie ID, so it just simply writes it movie ID, gender, age, occupation, ratings, and the movie mapper writes to the context movie ID, title, and category. So this becomes the key, the common key, and this is the thing. Now, the reducer has the actual logic of um, converting the age category code into the actual age category value. Same thing with the occupation. Now here is the output that I captured when I ran the job on my AWS instance. Um, the software requirements to run the code example, you need Java 1.6 or higher and Hadoop 1.1.1. And how are you going to run the file? This is the command that you're going to give: Hadoop jar outer join demo.jar. The input file locations. This one is the sorry about that. This one was the intermediate file location and the final location. Now let me show you the here how to run. So let us run the code. I have it in history. So let us run code and see. It's very fast in here. This is an Amazon AWS M1 large instance. Yep, it's pretty fast. Now let's see the output. Let's see the first 10 rows. Oh, sorry, the command should be cat. Yep, here you can see the first 10 rows. So as you can see, the genders, the age categories, again, it's between 50 and 55, 25 to 34, 45 to 49. So these are all the categories. Again, these are the various occupations like self-employed, executive, graduate, student, technicians, and whether likes or dislike. And this is the movie title and the category of the movie. So multiple users have rated the same movie. Now to show you the outrage on example, so let's grep for not being rated. That will actually show, yeah, see there it is. So these are pulled out from the movies even though they do not have a matching key in the ratings data, in the ratings input. So this is how it look like now. Um, yep. So that's about it. The code and everything, the zip file is included as a part of the submission. It could be downloaded, compiled, and run on any Linux machine. Thank you very much for your time.